Okay, so the purpose of this video is to look at some multi-step inequalities and show what it's going to look like when you might have a situation in which your solution could be all real numbers, essentially meaning infinitely many solutions, or when you don't have a solution to a multi-step inequality. And so we're kind of coming into this with the expectation that we kind of know how to solve inequalities. We just want to look at what the solutions mean. So let's go ahead and work through this first inequality. And so my first step is going to be to distribute on my left side. So 2 times x is 2x. Okay, and then 2 times negative 4 is going to be negative 8 is less than, well, we have some like terms we can combine. So 4x minus 2x is going to be 2x. And then we just bring down that plus 7. Now, here's what we notice. Well, we have a 2x on this side and a 2x on this side. So the coefficient is the same on the left and the right side. And we have the expression 2x minus 8, and that is less than 2x plus 7. So what we do here, typically if we're trying to solve an equation or an inequality that has variables on both sides, we want to move the variable to one side. But if we were to do that, we would essentially cancel out all the variables in this equation. So what I like to do is just say, okay, well, if I have the same coefficient, the same variable on both sides, let me just mark out my variables. Let me just go ahead and just cancel those out. And now I'm going to rewrite everything I have left. On the left side, I have negative 8 is less than, on the right side, I have 7. So negative 8 is less than 7. And now that's a true statement. So negative 8 is less than 7. So what I like to say is that if you cancel out your variables, as long as the coefficient is the same and you're left with a true statement, then that means this inequality essentially has infinitely many solutions, or you could say that all real numbers are solutions to this inequality. Now the purpose for that is, what we mean by that is that you could pick any value to go in for your variable. So if I could pick any value, I could pick 5, I could pick 1,000, I could pick negative 54.2, I don't know, anything really, and it could go in for my x here, here, and here, and what would happen is it would make this inequality true, meaning no matter what I plug in for my variable, my left side is always going to be less than my right side. So no matter what I pick. So that's what we mean by all real numbers or infinitely many solutions, is any solution or anything you'd want to plug in for your variable will make the left side, in this case, smaller than the right side because of the sign of inequality that we're given. Alright, so now that we've looked at an example that has all real numbers as a solution, so infinitely many solutions, let's look at one that would have no solutions. And I think you can kind of see where I'm going with this. It's going to be very similar to how we did the last one, but let's go ahead and simplify this inequality. And what we're going to do first is we're going to combine like terms on the left side. We get 8y minus 4. Okay, and that's going to be greater than 8 times y, which is 8y, and then 8 times 2, which is positive 4. All right, and so now, just like last time, what we're going to do is we're going to go ahead and just cancel out or mark out our variable because the coefficients match. We have 8y on the left side, 8y on the right side. If you were to try and move the variable, they would cancel out anyway, so we'll just mark them out. And so we're going to write what we have left. So negative 4 is greater than positive 4. Okay, and now that is an untrue statement. So, kind of essentially the same thing as the first example, except now if you're left with an untrue statement after canceling out your variables, that means there is no solution. So in this case, you would have no solution. So what that means for our inequality up here is that no matter what value you were to plug into your y all throughout the inequality, the left side will never be greater than the right side. No matter what you plug in for y, the right side will remain the greater value, even though the inequality says otherwise. So that's why no solution would work for this inequality right here. Now let's look at one more inequality, and let's just see what happens as we simplify this inequality to work towards solving it. So we have 3 times x minus 4 plus 10 is greater than or equal to 5x minus 2 minus 2x. So I see a couple things I can do on both sides of the inequality. So let me distribute my 3. So we get 3x minus 12 plus 10, and that is greater than or equal to, well, 5x minus 2x is going to give us 3x minus 2. All right, so one more thing I see that I can do on the left side is I can combine my like terms. So that's going to become 3x minus 2 on the left side. So let me just rewrite my left side real quick to get 3x minus 2. And so now what are we noticing about both sides of this inequality? Well, it's 3x minus 2 is greater than or equal to 3x minus 2. Now, what's that mean? Well, let's think for a second. If this were an equation, if it was 3x minus 2 equals 3x minus 2, we would say that this has infinitely many solutions, because no matter what value you plug in for x right here and right here, you're going to get the same value on both sides. You know, if I plugged in a 2 for x right here and right here, I would get 6 minus 2 on both sides. So 6 minus 2 equals 6 minus 2. And so again, no matter what you choose, you'll get the same value on both sides, so there's infinitely many solutions. And now, essentially the same thing is going to be true for this inequality now. Since we have the same thing on both sides, like with the 3x minus 2 is greater than or equal to 3x minus 2, no matter what I plug in for my variable here and here, my left side is going to be equal to my right side. And now that's okay. And the reason that's okay is because we also have the equal to portion of our sign of inequality. So no matter what we plug in for x, so for example, let's say that we want to use x equals, I don't know, negative 2. So that'll be 3 times negative 2 minus 2 is greater than or equal to 3 times negative 2 minus 2 on the right side. Now 3 times negative 2 is negative 6. Negative 6 minus 2 is negative 8. So negative 8 is greater than or equal to negative 8. And now that is a true statement, and that will be true for no matter what you pick. And so because our sign of inequality also includes the equal to part, we would say that the solution is all real numbers, or you could say that there are infinitely many solutions. Those kind of mean the same thing. Or you could also use this sign that is used in mathematics to stand for all real numbers being the solution.